My name is METİN Arıdaşır. This is 153rd part of explanation of my theory. Arıdaşır's mine proven spectral theory. Arıdaşır's prediction of multielectron lithium spectral lines. According to my theory and my formulas. 1. All of electrons in all known atoms have same initial wavelength. When they were free or when they bound to only a single proton, their initial wavelength is lambda normal, remember, 91.155 nanometer. When they are free. Most common wavelength size kind of electron motion forms wavelength in our universes. Yes. Remember 2 days ago, remember from my previous video, I have computed and I explained lithium atoms spectral lines. Again, first page, I hope you see here. Right side NIST data, National Institute of Standards and Technology, Physical Measurement Laboratory data. Right side, left side, my prediction according to my theory and my formulas. First page, second page, snapshot, fourth page, then, pardon, I'm so sorry, third page, then fourth page. Yes. You can watch my previous video. Yes. Now, two. Protons constituent parts are electron-like motion forms. Therefore, in spite of they are not electron motion forms, a kind of imbalance makes protons behave as a motion form, which has an axis, motion axis, cycle axis. In fact, this axis belongs to protons' constituent parts, say, belongs to quarks. Joint cyclical motion axis. In fact, this axis belongs to protons' constituent parts, say quarks, joint cyclical motion axis. This is proton, but it has constituent parts, okay? It's not electron motion form. Its constituent parts are electron motion forms. Yes. Protons make joint motion side by side by entangling. This structure is multi-proton. Here multi-proton. This is first proton, upside, side by side joint motion. This is second proton for lithium, downside. This is third proton, upside again. And around this multi-proton structure, say, free electron motion forms, which their initial wavelengths are 91.155. Okay. Yes. Yes. Protons make joint motion side by side by entangling. This structure is multi-proton. Each single cycle axis linear velocity, this is one axis, second axis, third axis, okay. They feed themselves. Each single cycle axis linear velocity is 1,884,000 km per second. Remember from my former videos. When protons make joint motion with each other, without change of this linear velocity, their constituent parts shrink and their frequency increase. Per connected addicted proton, this frequency must be increased at the rate of squared protons number relates to their addicting linear velocity. According to me, Arıdaşır, N always represents wave number, which is multiple of first cycling linear velocity. All they are in their first cycling, because of only free electron motion forms can produce and propagate successive waves. But when they bind, when they joint motion, they stay at their first cycle always. Cycling goes on. Okay. And first cycle's linear velocity is always 1,884,000 km per second, and electron motion forms each successive waves, free electron motion forms, first successive, second, etc., goes on, multiple. If second successive wave, its linear velocity will be 2 multiplied by 1,884,000 km per second. So, yes. 3. When 91.155 nanometer wavelength size free electron motion forms coincide, meet. Here 91.155 nanometer wavelength size free electron motion forms, initial wavelengths. When they meet proton structure, when they coincide proton structure, when 91.155 nanometer wavelength size free electron motion forms meet with multi-proton structures, they forced to change their initial normal 91.155 nanometer wavelength, but first one's wavelength always decreases inversely proportional to squared proton's number. This first proton connected electron always shrinks inversely proportional to proton's number. Like what? Like this. Remember from my former videos. Here, snapshot again. Yes. Four. When 91.155 nanometer wavelength size free electron motion forms coincide and connect with multi-proton structure, each electron motion form is from now on proton-bound electron motion form, p-bound electron motion form, and each p-bound are forced to change, and each p-bound electron motion form are, and each of p-bound electron motion forms is forced to change its initial 91.155 nanometer wavelength and resize differently. Different wavelengths they share. Okay. Not they share. They have. 5. There is only one different wavelength size electron per proton. Now, each of p-bound resized in different wavelengths electron is in new imbalance conditions. Like what? Left side. All bottom values. For lithium, snapshot. Notice please. This is 10.128 nanometer, smallest first bound p-bound electron motion form to first proton of 3 protons lithium, and corresponding initial imbalance energy is 122.38 eV. Then here initial imbalance bottom values, okay, n equal 1. Forget energy levels of accepted physics, Schrödinger equations, uncertainty principles, quantum physics, quantum chemistry are not valid. My theory, Arıdaşır's theory, is valid and proven with these figures. When we match experimental measurements figures, they are in accordance with. Yes. Then, second electron of lithium, 16.38 nanometer, imbalance initial in lithium atom, and corresponding energy is 75.64 eV. Then third, but now I said here first, third. In fact, I don't want to confuse. Smallest electron that connected with proton, first proton, I named lambda 3, energy 3, okay? Like third electron, but don't confuse, please, okay? Yes, here, this is, say, smallest electron motion form, okay? This is second, this is greatest electron motion form, 229.9 nanometer and corresponding 5.39 eV. Initial imbalance, okay? Now, I'm sorry. Wait a moment, please. Each of these proton-bound electrons have an imbalance ionization energy, or you can say ground state energy. This is smallest electron, first bound proton, but I put figure like 3, lambda 3, energy 3, okay? But smallest one, 10.128. I don't want to repeat now. Yes, I hope I can tell you. In general picture, they are intertwined. Like what? First electron, second electron, and the other, intertwined, okay? I advise you to watch my previous video. Unless they disturbed by effects from outside, they can never produce light, okay? They can never produce light. 6. Electron motion forms are capable of enlarging, expanding, or shrinking under the special conditions. For instance, p-bound, proton-bound electrons. For lithium, there are 3 wavelength-sized electron motion forms here, and initially an imbalance, they have different imbalance wavelengths and corresponding energies. Look at the bottom line here, 3 different electrons, okay? Each of proton-bound electrons, wait a moment, electron motion forms are capable of enlarging, expanding, or shrinking under the special conditions. For instance, proton-bound electrons can enlarge, expand by the effect of free electron motion forms, successive waves from outside, okay? Not inside. Maybe sometimes inside, maybe in atom, one of electron motion form break down its bound, then starts to produce and propagate successive waves, okay? But I don't want to confuse your mind now. For instance, proton-bound electrons can enlarge and expand by the effect of free electron motion forms successive waves. Here, wave number of effective successive waves is important. Each of proton-bound electrons, whether their wavelengths different or not, this is not important. They respond to effective successive waves of free electron motion forms in same way. They enlarge, expand their initial wavelengths at the rate of squared successive waves number. My absorption definition is just that. For example, n is equal 1 in balance, initial values, okay, energies and wavelengths. This is smallest electron, this is medium electron, biggest electron in lithium. Now, if second successive wave affects these electron motion forms, p-bound electron motion forms, multiplied by 4. This one will enlarge to 40.500 nanometer, and its energy will decrease 30 eV, 30 point eV. This one, 16.38 nanometer, will enlarge to 65.52 nanometer, and its energy